This is my presentation for the game of name. What we'll look at are the problem description, the problem solution, and the conclusion of the report, the presentation. Briefly, the history of name. The origin are still uncertain, and Charles Boutor in 1901 developed the complete theory of the game, including a winning strategy. The game of name starts with the number of piles or heaps, and the heaps contains coins or stones in this case, and it's a two-player game, so the player take different turns. So on each turn, a player must choose one pile and remove at least one object from the chosen pile. So you can remove at least one stone or coin from the pile, or you can remove all the stones, but you cannot remove it from different piles. You can only go to one pile at each turn of your play. So we have two modes of play. We have the normal play, where the player who removes the last object is the winner, and misere play, where the player who removes the last object is the loser. So how to play and win? For the normal convention, we convert it the size of each pile to its binary notation, and we add the columns up independently, and then the resulting value of the addition is the name sum, as you can see on the example of three heaps of 745 coins each. So winning and losing position. So a winning position occurs when the name sum is equal to 0, and the losing position occurs when the name sum is greater than 0. So we can pretty much look back at our previous slide and just see that the name sum here is greater than 0. So we know that we are in a losing position. Once in a position, the next move will always result in a losing position, and a player can always move from a losing position to a winning one. So the optimal strategy is to always be converting losing positions into winning positions on each move. This is a bit explanation of how to strategize a win. So if the name sum is greater than 0, we know that at least one of the columns is 1. So if you want to move it to a winning position, you convert you change the digits in the columns where the name sum is 1, starting from the one with the most of the left side. So for example, this is a 4745. When we change it to binary 725, it will be a name sum of 0. So this game has two absolutes. A player cannot move from a winning position back to a winning position, and every losing position has an allowable move to a winning position. We definitely assume both of the players are playing with optimal strategy. So if it's that way, then the winner is determined by the starting position of the game. If the game starts in a losing position, then the first player to make the first move will win. And if it starts in a winning position, then the second player to move will ultimately win. The player who removes the last object loses. This is in misere name. So therefore, the goal is to leave the last object for your opponent to take. The winning strategy is you have to play exactly like you would in a normal play until your opponent leaves one pile of size greater than 1. So according to the documentation, I just used just two snippets. One snippet shows a calculation of the name sum, and the other one shows a function that makes the move in the name game. As you can see, these challenges. You have to understand the combinatorial game, understand the Bouton's theorem, translate the logic to computing codes, understand the game rules and factors. And we have the algorithm limitations. Human opponent is assumed to play optimally. algorithm will only act based on the name sum, and there's different time wasted for each turn's calculation, and there is no randomization or other information hiding strategies. These were my references, and more about the game of name will be indicated in the report. Thank you.